Hello. Let me see if I'm live right now. Yeah, so we are live. So this is our part, I guess, 9. And we'll start from modules, which is module of 10. In this, we have various subtopics, but inside those subtopics, there is no subtopic. So it'll be a short, might just be completed in 1 hour. So if it gets completed and we have a hour remaining, we will start with our crates. All right. As for cargo, now this is also small. So today our goal will be to complete all of this. But if somehow we lag time, we'll end it in modules only. So let's start. Modules. What is modules? So Rust provides a powerful module system that can be used to hierarchically split code in logical units. That's called module, and manage visibility by saying pub or या फिर private. So it's public or private between them. A module is a collection of items, functions, structs, traits, and implementation blocks, and even other modules, right? So for visibility, by default, the item in a module has a private visibility. So if you don't write something like pub or something like that, pub, it's private by default. Otherwise, if you write pub, now it becomes public. So but this can be overridden with the pub modifier. Yeah, like over here, it's also modified. Only the public item of a module can be accessed from outside the module scope. I don't know what that means, but it sort of means that all the public items in this module can be accessed out of this, module in outside any sort of code where we are importing this module. But this private function cannot be used by the modules outside. That's what we see. Yeah. So this is a long code. Let's go by line. So a module is named as my mod. That's why it is mod, which is declare module, and it is named as my mod. Then we have a sort of method or function inside that. So items in module defaults to private visibility. So fn private function. So there is a private function inside this module which just says that call my mod a private function, called my mod and private function, but you will not get anything because you can't call it from outside. But from here, yes, you can. So it's just printing, nothing else. Now use pub modifier to override default visibility. So we have used pub, which is public flag, which modifies this function as a public module. So fn function, which is print, and now this is called by mod function. So whenever this function is called from this module, it will be called because it is public first of all, and then it will just print. What this function will do is just print. Every function is mostly just printing. So it just prints that called my modifier function. Now for this private module, we are calling it in a public module. So what will happen? So items can access other items in the same module even when private. So this can now access the private module sort of publicly, even when this function is private in a module. So now this is sort of indirect access, and it prints that called my indirect access, that is sort of called my private function. That's what will happen. Now modules can also be nested. So we are declaring a module, a public module inside a module. So first the module name was mymod. So inside that mymod, we have declared a module named nested. So modules can also be nested like this. So earlier was also a module, and now this is also a module. So yeah. Now there's a public function which says called mymod and nested function. Now this is nested, and inside that we are declaring a function. So yeah, mymod, then two colons, then nested, then two colons, then function, and calling a function like, parenthesis. Now we have a flag that allow dead code. Otherwise it would have caused some sort of warning issues. But all right. So inside that we have a private function, and we are saying that we have, if we access it somewhere, we'll call it something like called mymod, like the earlier module. Inside that a nested private like this. Inside that a private function. Oh, not nested private, it was just nested, and inside that we have a private function. So this was named as private function, and we are then using parentheses to call that function. So we have some sort of idea because we have used create and modules, like we have made our Rust programs like compute engine and all other sort of programs. We have made some. All right. So it's not like we are unfamiliar with this stuff, but yeah, we don't know it in a great detail. I just copy and paste, not paste, but copy and write whatever it gives me. So that's what I did to understand it. But still, we have an understanding that this is like, this seems familiar if we don't use colon, and sometimes we have to use, dot, where we use just dot, where we use just colon. So we don't have much of a clarity over there, but we are very familiar with this type of annotation. And if we want to, sort of say that my mod nested should be imported in sort of my code, then we'll just use the use sort of syntax. So we'll just say use my mod and nested, and that will do the same thing. And then I guess we can call private function, other functions, other nested modules. Oh, sorry, this is the nested module. So let's just say my mod and nested. That's all. But we know this side of this sort of annotation. Now we are in a sort of function declared using pub and in path. So we are saying the path, we are saying pub, and we are saying in. So now this is interesting because we are declaring a function that is public and in path to this, like create and my mod. Syntax are only visible within the given path. Now path must be parent or ancestor modules. So my mod is a parent module of nested. Yes, it works, but why do we have to use it? No idea. So function is called the public function in my mod, and then we are printing the my mod nested public function in my mod, and that is we are printing the public function in nested. So where is the public function? Public function nested. So we are calling it again over here, like calling it for here. Like we are just printing it. We are calling it, and it will just print that again. What happens if we, call it one time? It will print this again. Then it gets called again and it gets printed again. So does it go on or does it even stop? Because this seems like a recursive function which is calling in itself, and it has no exit parameter. So when will it exist? Oh, sorry, when will it exit this sort of recursiveness? I don't know. I don't see any sort of parameters if this is equals to 0 or something like that. Don't do this. I don't see that. Okay, first of all, let me check if everything is healthy right now. All the stream and all. So everything seems all right. Let's move on. We are creating a pub self called public function in nested. Oh, sorry. So this was not a recursive function. My mistake. This was named as public function in my mod, and this is public function in nested. So we are probably calling, yeah, obviously not probably, we are calling this function, not this function itself. So this line over here is calling this function, sort of public function in nested. See that? And this public function in my mod is not getting called inside this function. Otherwise, it would have been the same case that I've told, like it will be recursively called and nobody knows when it might stop. We'll try doing that. I think so. No, we won't. Let's understand this my mod and all that first. Now the comment says that function declared using pub self, which is like this. So we have first of all, pub in crate and my mod. So pub in path. Then we have used just pub, and that's it. So we first of all know that if we use pub, it will make it public. If we use pub in then path, then it will be available in that path publicly. So, and the path must be parent or ancestor modules. Now we have a new sort of syntax that is pub self. So we are making public and we are passing self in it. I don't know how that works. So functions declared using pub self syntax are only visible within the current module, which is same as leaving them private. What? Function declared using pub self syntax are only visible within the current module. So it will not be visible in the code that we import this module in. It will be only visible in the within the current module, which is the same as leaving them private. Yeah, it is. So we are creating this public function in nested, and probably this won't work because no, this will work because we are calling it over here. But we can't just call this publicly declared function because pub is using self and this syntax are only visible within the current module, which is same as leaving them as private. We can't use them while after importing this module, my module function, my module, all right, in another code. We can't just use this function. Now let's see this next one. So we have a comment saying that function declared using pub super. So this is our new annotation for what? So if we declare it using pub super, then syntax are only visible within the parent module. So then syntax are visible only within the parent module. I don't know what the difference is because it is also visible within the current module, and current module means this, whereas this means that visible within the parent module. Now what is the parent module? But let's see. If this is a super, it will be visible in a parent module. If this is a self, it will be only visible in current module. All right. And this will print something like called my bond nested public function in super mode. That's what it will call. Now we have another public function like call public function in my mod. And it just used the pub annotation, so no problem at all. And it says that call my mod, call public function in my mod that it just prints it, and then it starts to call something like nested public module in my mod. This. So it has to give, the path to call this function properly. So it is giving it a path that is nested inside nested. We are now using this public path, public function in my mod. Then we are printing this, caret or arrow. What is this? Oh, this is, this is caret. This is caret or had? This is cap, I guess. This is like greater than equal to, greater than or less than. This is what I call greater than. This is what I call less than. Yeah, it depends on the number. But since we are using it like an arrow, so we are saying after that we are calling function in supermod. So after this function, we are calling this function, and we'll call it using a path. Not just like it is there and we can just call it. We are using a proper path for them. I don't know why. So now let's see what is this. So we have a public, then inside that we are passing crate, and we have a function that is called public function in a crate, which prints the same thing. So public crate makes the function visible only within the current crate. And what is crate? We don't know yet. But we know that if we pass in crate after public, it will just make this function visible only in this crate. Now nested modules follow the same rule of visibility. What does that mean? So there was a earlier, remember that we have a my mod function. Inside that we have a again new mod or module, which is now called a private nested. Now it is a private nested. So because there is no pub mod like this, there's no pub mod over here. So that's why it is private nested module. But inside those we have a publicly available functions called function, and the path looks something like this: my mod private nested and functions. So nested module follow the same rule of visibility. Which same rule? Like this one, which one? Private parent items will still restrict the visibility of a child item even if it is declared as visible within a bigger scope. So private items like these will be still restricted, the visibility, because they are child items, and even if they are using some sort of declared as a visible within bigger scope. So we have flags again, like allow dead code. If this code gets sort of unused, that's why we used the allow dead code. But can't we just specify it at at the top of my mod? Will that not work? Why are we using it again and again? I have no idea right now. Now, outside of this module, like outside of this my mod, which was a private mod, not public because we didn't make it public, but inside that module or functions, inside that module, there were functions which were public, private, and all that, which we have seen for now. Now we are creating a function with just like called function. So this is a normal function outside of the module. Now inside the main, we are calling all these modules. All right. So I guess here we'll start seeing some output or results. First of all, let's remove these to-dos. Why? Because I want a bit of clarity. This is very long code in itself. But let's see what we are calling. First of all, we are calling this function, right? So it will be called like called function. Yeah. Then we are calling my mod function. Inside my mod, we have a function over here. So this will call my mod function. This will print my mod function. So it will print, yeah, called my mod function. Exactly like we expected. So modules allow disambiguation, like disambiguation itself, between items that have the same name. So this is function, but this is a my mod function because it is inside a module called function. Now, if I guess correctly, yeah, there is inside, my mod, there is a private nested. Inside that also we have a same named like unambiguous. Because of unambiguity or disambiguity, we have the same named function as function, but we are not calling it yet. But there shouldn't be much of an error just because we are calling this function and it has the same name as this function because we have a function like this one and we have a my mod. Inside that we have this function which has the same name but not exactly the same functions. All right. So this is calling a different function. This is calling this one. Modules allow disambiguation between items that have the same name. These have the same name, so modules allow disambiguation between them items. Now, public items include these inside nested modules can be accessed from outside the parent module. What does that mean? So inside my mod, we have indirect access. Inside my mod, we have a nested, and inside that function, yeah, and inside my mod, we have a call public function in my mod. And these all are working fine. But let's see them one by one. So we'll see this my mod indirect access. So let's see where it is. My mod and inside that indirect access over here. So we are calling this function like my mod indirect access. That is, and inside this function indirect access, we are also calling the private function itself. So this is a private function by itself. So we can't call my mod private function, but we can sort of, call this private function inside this modules another function which is called indirect function and it will print both of them. It will print like called my mod indirect access and after that it will just print that called my mod private function. Let's see if that what's happened. So yeah, private access, that means that we have a private function sort of there. Hmm. But I want to know something else. Like, all right, this is a private function we are calling it and we are calling a print statement. But where are we getting this, this sign from? Where are we getting this? I don't see any. It's just backslash and that is, new line. Does not mean that create that. And we have used the same name multiple times so that we don't lose our clarity because to call this, private function, we have to say, my mod nested and inside that we have to call this private function, but it will not be called directly because this is a private function. So we might have to use it somewhere else if you want to. All right. If you want to, we can call it somewhere else. Now let's see the second one. This. So now this is inside nested. We have seen it is a function and it just prints the same thing. Prints the my mod nested function. And that's exactly what it does. this one. Now we are calling, my mod. Inside that we are calling call function in my mod. All right, let's see if there is any. I don't see any call function in my mod. It is over here. And it is not nested inside this, module nested. It is just directly inside my mod. So call public function in my mod. This will be called, and it will first of all print that call public function in my mod, like walk path, and that after that it will use something like nested, which was this module nested. Inside that we have a function called public function in my mod over here, and that will be printed. And after that we are using this caret symbol. Deliberately we have this now, and it will not give us a new line, so remember that it is not print len, it is print. That's all. And after that we have a public function in supermod, so we'll also call this. And important, or curious thing to see over here is that we are calling it totally by their full path. No half path, no nothing, full path. Inside nested you have to go and fetch this public function in my mod, because we are calling these function outside of this nested module. So we have to use this, I guess. So let's see the output. Where were we? Over here. So it first of all, prints that it has been called, and that after that we have also called the public function in my mod, and then we have called the nested function in my nested. Something like function inside the function. Public function in my mod and public function in super mod. Super mod, and in my mod is something looks like. Oh, so in my mod also calls this. So we are calling all of these three. So we first print what? Oh, it's so confusing. But all right, we have to just use our pointers correctly, use our mouse pointers correctly to point what are we seeing right now. So we first of all print this statement, and after that we print this statement, which is public function in my mod, and then after that we are calling this function inside this sort of function. And what is this function? It is called public function in nested. So it will after that print this, and finally we have this, which is like public function in super mod. Now let's see the output. How about, like, we've used these, no? We'll just remove them. Yes, it has been a confusing time. So we see that we first of all call public function in my mod, and after that we get a public function in my mod, which is my mod and nested. Inside that we are seeing my mod nested public function in nested, which was called inside this public function my mod function. And after that finally we are seeing the super mod. Important. Super mod was called inside this call public function in my mod. Over here we've called super mod, so we get this thing printed. So no worries, we'll clear it also. We now know we have seen this call public function in my mod multiple times. Now if we just print this next function, which is my mod and public function in create, public function in create looks something like this, and it just prints that this is public function in create, and that's what it does. So now let's reset our code, And since we have used, public function in create and all that, we now know. So let's just comment them out like this. And there was another comment which we didn't sort of read, which says that public crate items can be called from anywhere in the same crate. So this is the same crate, so we can call it from anywhere. So this can be called from anywhere. All right. Now we have to-dos, like it says that public in-path items can only be called within the module specified, not outside it. So we should see some errors. So yeah, comment them back. And we want to see some errors. So after uncommenting this line or this function, we should see some errors. That is my mod and nested public function my mod. So in nested, we should see public function in my mod. What? We just did call it, didn't we? We called it over here. So are we seeing the same thing? The public function in my mod. Yeah, same thing. And it says it will not print. Why? You've called. Oh, all right. This is a different one. We have to see this is just public function in my mod, which is nested. Damn it. So we called this earlier, which called the public function in my mod. So over here, we have called this public function in my mod. But now we are not inside our module, like we are in main function, and we are trying to call this public function in my mod, which is declared for, create, but it still gives us the error that we can't use this inside nested module. We can't use this public function in my mod. I don't know why, but let's see and let's try to diagnose it. So it says my mod nested public function my mod, and it says public function in my mod is private. But we sort of called it, no? So I guess create means the whole module, which was my mod. So inside that we can call it. But outside that, my mod, like in a main function, all that, we can't call it. It says it is a private function, so public function my mod. So it is just public inside this mod, but outside of that module, it is private. So we can't just call it directly from the main. But inside the mod, we can call it inside any sort of function implicitly, like public in create my mod, public function in my mod. You're seeing that function is defined here. All right, so we know that this is only public inside, the module called my mod. Outside of that, it is not. So now there is a private item of module cannot be directly accessed even if nested in a public module. So it says that private items of module, so we have a module, my module and all that, nested module also. So it says that module cannot be directly accessed even if nested inside a public module. But we just have accessed it. Let's see where this function takes us. So this is just a private function declared. This private function. So we can't just directly call it. Yeah. But we can, use indirect access to call indirect access, and that will call this private function. Game equal, but we can't just call this. So yeah, now we are expecting errors. This is not any sort of. So we now see that it says it is a private function and it has been defined on line 4, and which is true. Everything is true right there. Now the next one. It says that error private function is private. So inside nested also we have created a private function. So let's go and see. Inside nested we have a private function, which is again a private function. Alright. And we can't call it directly. We'll get an error. Obviously. So we see an error, which is saying the same thing, just now inside a nested module. So it is inside two modules, like first my mod and inside that nested module. Alright. We now know this also shows the same error, just the path changes. What is this? This is also private nested in a private module. So now we have a my module and we have a private nested module, and inside that we have a function. So let's see, where is it? We have my mod. Inside that, yeah, we have a private nested mod, and inside that we have a restricted. We have just a function. We have created just a function. This is what we are talking about. Just a function. This is public, but this module is not. So this becomes private. Does that become private? Private nested is a private module. Let's change something over here. Let's make it public. Not PUIB, but PUB. Yeah. Alright, so we were guessing right. Now we are not just guessing, we now know some sort of thing, that since this module is sort of private, because it is by default private, it has to be defined as public by writing PUB. But here it is not, so it is just private. Alright. Now the last one. After that, we will move on. So it is easy, but we have to keep a lot in mind. So even if something gets, even a little bit wrong somewhere, it causes a damn errors. Now it says it is again a private mod. So we are going inside my mod, private nested, and restrictive function. And we know why this will give us an error, because this is not a public module, it is a private. So if we make it public, we'll not see this error, or we'll see. No, we won't see. I thought, this was something like just a normal function. Something like this. That might give us an error. Yeah, it did. Because now we have made it private. But if we just do this, which is public, Inside that we are passing crate. I don't care what we are passing is. I don't understand what a crate is right now. But since we have passed public, now it will not show us an error that this is a private function. Now it will act or behave exactly like public one. And it gives us a printing message that it had. So I guess we got some points. We might have missed some other points. And this is a long program. Let's move on. Now struct visibility. This is a small program. Just three, things in main, and rest are just four things. If you have to, five things. Five things in a main. And a module inside that we are creating a struct called open box. Inside that we have a public content. Then we are creating another struct called closed box. Inside that we have again content, but this is not public right now. And all these T are generic T. Alright, so I will not just call it generic T every time. And we are creating an implementation for generic T. I just said it. After saying that I will not call it generic T right now. Because we all understood that this is called generic T. Because it's capital and it is T. Alright, so we are implementing for closed box that a new function should be there, which is public. So we have a public new function which takes the content of the closed box. Why doesn't it takes the self so that it can get self.contents? How is it getting a content? It is getting this content because of T. So we are creating a new function which is takes the content and passes or gives us a result which is of type closed box. And yeah, so this new function takes a content, it makes it inside a closed box, and we get a content. But now what we will do over here is there are some or this, first of all, this module is not public. Do we need to make it public to make it happen? No, not right now, because we are using it in the same code. But for using it in other codes, I guess we have to. But right now it is just getting used over here, so I don't think this will be necessary. Now, so somewhere we have public structs, whereas somewhere we have public structs but not the public content. And over here this is a public sort of function, but I don't know for implementation also should we make it public or not. So this is new for us, like implementation inside a module and then making it public or not public. All right. And inside this, we are doing something and we don't care about it. So let's see. So inside main, we are calling public struct with public field can be constructed as usual. So open box with, my module was the name. So it is my, and then we are using two colons and then we are calling just the open box. Inside that, we are passing a content and we are storing that in a variable called open box like this. And this will work because this is using our public function, and over here we are printing the open box and the content which is public information. So we should see this. Let's not see this right now. So we see the same thing that we wanted to see. The box contains and the public information. Now we created a variable called closed box, and if first of all we are creating it like the same my box, but we have to use implementation called new, or the function inside that implementation which is called new. And then we are passing our content which will then return a closed box which will be stored in a closed box, but we are not using this variable. Therefore, we are using underscore before naming this variable. So if we just run this, we don't get any errors because, but if we try to print it, it says we will get an error. Yeah. So we get an error called, this is a private field, so we can't call it. Why is this a private field? Because this is public, but this is not. But now we are calling content like it is public. So it says it is a private field. But as soon as we make it public, it's not a very difficult thing. We shouldn't see much of error. Yeah, we don't see much of error. So since this content thing was, not public, we can't just access it like it is. All right. So that's why we saw this error, and it was just, highlighting this content part, which is not public, which is a private. And the error says something like field content of struct closed box is private. Now we know, and we know why, and how can we improve that, or like how can we, debug it? We just have to make it public. That's it. But we still don't know what to make public, what not to make public. Why should we call it like this? Why can't we do it some other ways? And if we are not made it public, why would we access it, outside of its module or something like that? So there are many doubts, but right now we are learning bit by bit, like small things at a time. And we'll see this, moment after a minute or so. But right over here, we are trying to do something else, which is, just trying to call the closed box, which says my closed box, and we are directly trying to enter the content, which will not happen. Why? Can anyone tell me why this will not happen? Because content is again not public, so we can't just access it and say, hey, let's fill it up with something else. Therefore, this will throw us an error. But let's see and try and make it public. First of all, let's see the error. It is a long error. It sort of gives us something like we have an implementation for it, so use it. New is never used. It is a private, so we can't just, pass classified information just like it is not even private. We can't do that. But as soon as we make it public, all these error vanishes because now this is not a private, so we can call it like this, and it is now same as this open box, so no problem. Oh, we didn't print it, so let's print it, and the variable name is without underscore. Now, we sort of tested all these things. So I think let's read a comment and let's move on, because now we understand what this is doing. So yeah, public struct with public field can be constructed as usual, like this, and their fields can be normally accessed like this. And public structs with private fields cannot be constructed using fields name. So error will be that closed box has a private field, which is content. So we can't just call it until and unless we make it public. All right. Now to try uncommenting this line, we used it and all that. However, structs with private field can be created using a public constructor. So new was a public constructor, public constructor method. So we can create it like that over here. So we did it. And the private fields of a public struct cannot be accessed. Like if we try to access the content, we can't access it, but as soon as we make it public, we can. All right, I think we should move on. Now the use declaration. I guess we are on third subtopic, and after that we have fourth and fifth, and everything is done. So the use declaration. The use declaration can be used to bind a full path to a name to a new name for easier access. It is often used like this. So we have a use and create deeply nested. So somewhere we have a deeply nested module inside the crate, and inside that deeply nested we have multiple sort of functions called my first function, my second function, and a trait type. All right, why don't we use commas? Let's use a comma anyways. And then inside the main, we are just calling main function without using its full address like create, deeply nested, and my function. We just call it like this, and I guess we won't see any error. We won't see any sort of output because there is no run over here. But this is sort of just a short example. So the use declaration, I've sort of hinted towards this, that we can just type use and it will make this function available for this whole damn code, which is I guess create. But we are not sure if it is called create or not. But over here, this deeply, and inside that we have a nested module, and we are accessing it for the whole crate from the crate, I guess. And we are accessing the first function inside this nested, just like a normal function, just like it is declared over here only. But it is not. It is declared somewhere else. We are just using it over here. Sort of importing libraries and all, like in Python or, Next.js and all that. We are importing libraries using use. So it's different. So you can use the as keyword to bind imports to a different name. So bind the deeply nested function path to other functions. So we have now deeply nested and functions as other functions. So what is this doing? Instead of calling functions, we'll just call other functions and we'll get our output. So it's like import numpy as np. So instead of calling numpy every damn time, we can just call np and be done with it. So you can use as keyword to bind imports to a different name. Yeah. So bind the deeply nested function path to other function. So if we call other function, it will go and call this whole thing. So after that, we created a function which is called function and which prints the called function. And we are creating a module called deeply inside that nested inside that function that we have declared over here. But instead of just calling this function like normally we would, we are using use keyword and we are aliasing it or sort of binding it to other function named. So if we call the other function, it will call this function because this is binded together, and this will then print that called a deeply nested function. That's it. So easier to access this deeply nested function. And then we have a print statement saying that entering the block, and inside this block we are declaring just the use deeply nested function, and it will also call the whole thing like normally it would over here. Where is it? Yeah, this one, deeply nested function over here. So this is equivalent to using use deep nested function as function. Now this function will shadow the outer one. So this will now shadow the outer one, and use binding have local scope. So in this case, the shadowing of function is only in this block. So it will just shadow it in this block. As soon as we get out of this block, it will not. And we can also call it like this a normal function because we have already used this function, but we have binded it to other function, but we have declared that there exists something like deeply nested function. So we can just call it like this, and we can say leaving the block. After that, we are calling this as a function again. Now let's see. Oh, not equal. So everything is working. We get no errors, and we are calling, called function again. This one, first of all, prints the deeply nested function. Then we are entering the block, and then we call this deeply nested function. And after that, we didn't use this because this has been overshadowed by this. That's what it says. So use binding have a local scope. So this one has a local scope. Oh shit. Sorry. I made a mistake. I thought we were calling the deeply nested function. I probably didn't see use. So we are first of all overshadowing this use declaration over here by just saying that we'll just use the creates deeply nested function as just function. We are not aliasing or binding it to some other sort of fn or some other thing. And then over here we are calling function. We are not calling it 2 times or 3 times. All right, we are just calling it 1 time inside this scope, but after using a use function. And the use binding have a local scope. So this has a local scope over here. So as soon as this scope ends, this use declaration will be null or nullified. But this has a scope which is sort of global for this code. So the binding of use binding have a local scope. In this case, the shadowing of function is only in this block. All right. And then we say leaving the block, then we are calling function again, and we called it. Because of this? No, not because of this. If we just do this, we'll get an error because we are calling it function. But we won't. Why? Because it is over here. That is function. Now, if we shadow this or comment it out, we will get an error saying that other function is not found in the scope. So if we comment this out too, we get a normal functioning thing because we have declared it only over here. But oh shit, I again understood this code wrong. We again have a function called function. First of all, stop naming these all things as so damn confusing. There's another function that is declared like normal function would be, and we are accessing that function over here. We should also access that function over here, but we have overshadowed the normal sort of declared function by using this function. So sort of we have used this declaration that we are going to use the create deeply nested function over here. So as soon as we call function, we instead of calling this function, we get to call this deeply nested function, and outside of this, we are just calling this function. So called a function. Now run it and let's see. Yes. So at the end, we are just calling a function called function, and over here we have the same syntax like this, but we are not calling this function. We are calling this one called deeply nested function. That's what we see. All right. Now I got the point. Yeah. That's why I used the same name so that we can see how it gets implemented, where it can shadow other same named functions. So we can't just call now this function or the normal one that we declared over here. We can't just use this even if we type 100 times, because now this will just print this function, or we'll call this function as function. But if we use as and do, and then this function will call the normal one, because now we have used alias. So if we don't use this aliasing thing, we'll just call it normally. But as soon as we use the alias called do, now it will print whatever we wanted to. And it seems okay. All right. Now let's move on. We have a super and self. I guess this is fourth one, and we have not R left. So this stream is gonna end after file hierarchy. So let's see. Super and self. The super and self keyword can be used in a path to remove ambiguity when accessing the items to prevent unnecessary hard coding of paths. So yeah, hard coding paths is a drawback. So the super and self keywords can be used in the path to remove the ambiguity when accessing items and to prevent the unnecessary hard coding of the paths. So now we have a normal function which will, called function. Inside that we have a module which is called cool. Inside that we again have a function, the same named damn function. But since this is inside cool, so it is like cool and then colon and then function. Now that will print this cool colon function. And then we have another module called named as my. Inside that we have same named function called function, but since it is inside the my module, so we have to call something like my and colon function. Then inside this my module we have another nested module called cool. We have this cool, but this cool is different because this is declared inside a nested module. So we are using the same name so that we can see that this cool will be understood as differently as this cool, because this is different. This is a different module, whereas this one is a different, because this is nested inside my module colon cool. Inside that we have same named damn function, but it is different because it is inside my module cool and then function. So now it will just print that my module colon cool colon function. All right. And then inside this my module, we have a publicly declared indirectly called sort of function. It is named as indirect call, and what it does, it prints first of all that called my indirect call, and that is so over \n we are using this one. So we'll see some things. After that we are calling self and then function, which is what? Which one is it? Is it this one, self and function, or is it this one, that indirect call is taking this as a self and this as a function? I don't know. Now we are calling just function, so I guess this self function is this one and this function is the normal one. It's my guess. All right, then we have a self cool function, which is self my, and then we have a cool function which will print this my cool function. Then we have a super function. Now what super function is, like, I am guessing this one. And we have a create cool function. Now inside this create we have this cool module. Inside that we have a function. So we'll print it as root function and it will get printed. And then finally we are calling this my module and indirect call. So my module and this indirect call, and this indirect call will print or call every damn thing. Now let's see. So first of all, it says called my all that. After that, it says my function is called. Which one is this? Yeah. So I guessed correctly that self means my module, because public or function called indirect call is inside this my module. So we are just calling self function, which means this one. And after that, we call a function, which is called function, like normal, called shade. No, no. So that's not what's happening in this line. Damn it. Damn. So even if we call the function like normally one word to call this function, because there is no self or any sort of that, we don't get to see what we wanted to. We still see that it is a function inside my module. So we again sort of saw this one without even using the self. Damn. Now we have a self cool function. So in self, like module my, we have a cool function to show this should print something like my cool function, and that's what it prints. So no need to worry about it. We can remove it, and then we have a super function which will, I guess, call this one. So called function, cool function, yeah. So using super gave us access outside of this my module. And then we went to this and we called this, which was there. So super function, all right. And now inside a scope or a block, we are first of all saying use create cool function. So this is this one. That's what I guessed. And it says called cool function, nothing else. So yeah, that's what you see. And we are accessing it as root function, changing the name. And that's it. But let's read these comments, because if we had read these comments, we wouldn't have made the mistakes of assuming this function same as calling this function. But this is a super function if we call it inside from a module called my, indirect call. But if we just call a function, it will just call this one, because that's easier to access. Now let's read these comments and let's move on. So let's access all the function named as function from this scope. All right, we will. So the self keyword refers to the current module scope over here. So self, yeah, we sort of guessed that, but still we made a mistake. Calling self function and calling function indirectly both gives the same result. See, it's declared over here. Like it's trying to teach us, but we are closing our eyes and guessing by ourselves. Because they refer to the same function. Yeah, they did. They did refer to the same function. I thought it would not, but it did. Now we can also use self to access another module inside my. So we can use self to access another module inside my. So we are using another module called cool, which one was, cool. And then we were using, we were calling the function inside the cool, and we did. Now, super keyword refers to the parent scope outside the my module. So super will call outside of this my module, go over there and call this function, and that's what it did. So this, now this will, now we are talking about this. So this will bind to the cool function, which is cool and function, not this cool function, as root function, and we'll do that. So this will bind the cool function to the in the create scope. So in a create, not in a my module scope, in a create scope, we have a cool function and it will bind that to something like root function. And in this case, the create scope is the outermost scope. So create scope is the outermost scope. So we start seeing it like this, not, like from it's starting from my, anything like that. And that's it. That's it. Now file hierarchy is, I guess, the last one. It is. And we sort of see what is tree command. Tree command is very simple. It gives us a tree of directories, of files, or anything like that. It gives us a tree. So if I again say tree, see, gives us a tree. So we have a tree, and we have first of all my.rs, then split.rs. Now inside my directory, we have an inaccessible.rs and nested.rs. So module can be mapped to a file or directory hierarchy. Let's break that visibility example in a file. What does this open? This is ugly. Visibility. Inside which one? So this is the visibility that we have already read, sort of studied today only. So it is referring to this visibility only. So let's break down the visibility example in the files. We don't get to run anything. Oh damn. There is nothing to run, so it is just a theoretical part, and after that we will end this stream. So module can be mapped to a file or directory hierarchy. We know that. We have seen tree, and we know this is a my directory. Inside that we have inaccessible.rs and nested.rs, and then outside of this, in root we have my.rs and split.rs. It's root directory for this project, I guess. So it says in split.rs we have written something like my. So it will call this one. I'm guessing that. So this declaration, no need to guess. We'll just read it through. So this declaration will look for a file called my.rs, which is over here, and will insert its content inside this module named my and under this scope. So it will get under this scope. And then we are calling a function which is like called function, and from main we are calling my, and inside this we have a function we'll call this, and from my indirect access, our OBS is doing some sort of, all right. So my function, so inside my module we have a function like this, but if we just call a function without any my, so it will just print this one. And then if we see something indirect access, we have indirect access which reads the private function. So we'll get first of all my indirect access and then my private function like this. So now we are using different files to keep different things stored very, I guess, quality wise. It's now a very good example. Instead of just getting all these damn same names in a same sort of code file, that's very difficult to read. But now this is very, I will call it uniform to read. Now we have a my and nested function. So inside my, do we have a nested function? Yeah, we do. So it's not this my, it is now this my. We have nested.rs, and if we call my nested function, so it gets into my, and which is a directory, and inside nestedx. But we have not declared the directory, no. So how can it do that? But it does, because now we are saying that yeah, we have a private function inside nested.rs, and we are sort of calling a function inside it. Do we have a function? We have a function over. So it will give us a result of my nested function, and we have then inaccessible rs, which is good, but we are not accessing it because it is inaccessible rs. So this one is done. Sort of split.rs is done. My.rs is not calling anything else, so it is also done. My nested is not calling anything else except its own thing, so it is not calling anything. Now inaccessible.rs is doing what? Inaccessible.rs is not getting accessed by anyone, is not accessing anyone, so it is just there. Now let's check that things still work as before, and we do this. So rust c, and we say split.rs, and then we run the split which gets created, and then we see the outputs, which is called my function, called my indirect private access, and all that. So I guess, how about we have seen that what happens. We know this will be the output. We know that. but still, let's make it in Rust and let's make a directory, 10. Let's get into 10. Now, over here, we'll call first of all my.rs. First of all, touch all things. All right, touch my.rs, and then we have a split.rs, split.rs, then inaccessible.rs. Then inside a directory called my, we have a inx. This will not happen because we have not created a directory. So let's create this. Now make a directory called my, and inside that we'll touch something like in accible.rs, inaccessible. Oh, sible. Right. In acceess, inaccessible, and then nested.rs. Then we'll say my, oh shit, it should be like this. So nested.rs, we have to remove some things, but let's remove the my, then inaccessible. B. So tree is correct. Yeah, like exactly the same one. And now let's create all the files, split.rs, and we will, not this, we will copy this split. Is it copied? Let's paste it. This is a split.rs. Now my.rs. All right. Then we copy this nested.rs. Inside my, we have a nested.rs. Then we use my inaccessible.rs. My inaccessible.rs. Inside this. Now we have the same thing, but now it is filled. Now try to run the Rust C, which will call splits.rs, and like after compiling, it will run. So run the Rust, not Rust, sorry, split. So we see the same output that we expected. Same output as we expected. Exactly the same. Now, shall we match it? So my function, what will this call? It will call this my and this function. So it will call something like called my function. So let's see. It says called my function. All right. Now the function. So this should call this. So it will call called function. It says called function. And now we have an indirect access. So inside my, we have an indirect access. So first of all, it should call something like my indirect access, and then it is implicitly calling private function. So we'll see something like called my function. So we should see both of them. First this, then this. All right. So we see indirect access, that is my private function. Sorry, my private function is this. Yeah, that's why I see my private function, not just my function. So my private function and my indirect access, it is getting called by this one. And then we have a nested function over here. So inside my, we have a nested function like this, and this one is the function. So my nested function will get called. And that's what happens. So good for us. Now we know, but we still don't know the crate. So the next module will be crate. And this is the crate. Shall we complete it? I guess we could, if it's not that long. It is not. So let's do this. Let's do this. Because we still have, you know, time remaining. So create. Create is a compilation unit in Rust. So whenever the Rust or somefile.rs is called, somefile.rs is treated as the create file. So if somefile.rs has mod declared in it, then the content of the module files would be inserted in place where mod declaration in the create file, which is somefile.rs, are found. So before running the compiler over it, in other words, the module do not get compiled individually, only crates get compiled. So we don't have to, after creating the whole, inaccessible.rs, nested.rs, my.rs, we don't have to, individually sort of, what do we call it, compile it. We don't individually compile it. We have a crate which is split.rs, and inside that we have declared a module called my, and that is sort of compiling each and everything. And that's what I get from this point. So in other words, module do not get compiled individually, only crates get compiled. And a crate can be compiled into binary or into a library. And by default, the Rust C will produce a binary from a crate. And this behavior can be overridden by passing the crate type flag to lib. All right. So if we say something like, first of all, remove whatever we have. Remove what? Remove split, because that is the compiled version. We don't want that. So now we'll run Rust C, and we'll try to, first of all, run this in on split.rs. Then we use a crate type flag, which is, why don't I get it? Why don't I get to use this flag? CRAT crate type, and then I have to say lib, then I say split.rs. Since I had never used it, if now I see something like tree, it is a rlib. So yeah, it did create a library out of it. So how do we use it? How do we use it? I have no idea, but now it is a library and it is giving us multiple warnings because libraries cannot have these many, so these many warnings because it is a library, so anyone can access it, anyone will use it if they want to, if we make it public. So we shouldn't leave much of a, even the warning stuff, and we should not suppress it. We should just eradicate those warnings by their root cause, so that our library is more safer to use. That's what happens. So in other words, modules do not get compiled individually, only crates get compiled. All right. A crate can be compiled into binary or into a library. We have created a library using this, this function, this sort of command. Let's see if we can do the same, just not like this. Remove this lib, and now let's see the tree. It's normal. And now instead of calling splits.rs over here, let's call it over here. splits dot rs, not s, split.rs. Then give it a space. Let's see. Yeah, I guess it does. We have still created a library. So the flag, the position of the flag doesn't matter whether it comes after Rust C or whether it comes after the Rust C and file name. That doesn't matter. It's just it should have a crate type and then flag to library. That's what it needs. Now we see creating a library. We actually did create a library. So yeah, exactly like this, but on our sort of functions. And we see something like r.lib. That's what we saw, r.lib, but it is for lib split. So yeah, We know how to do this because we have I'm using a library. So what I'm thinking right now, let's do this, but different. CD make directory called 11. Inside that, get into 11. Now we should create rary.rs, vim rary.rs. Now inside that, we create something like public function and then public function indirect access. Public function, private function, and indirect access. Sorry, insert mode, a public function called public unctiun, public function. It does nothing except then printing. It prints. Print is a macro. Println is a macro. So yeah, what it prints is public unctiun. The function is getting called. Pub and called rary public function. All right, let's do that. CALLED called RARY. Raise public function. Now what? We'll create a function, isn't it? Not public, just function to declare a private, because anything that is not declared public is private in itself. Like anything that is not declared mutable is immutable by default in Rust. And then we say print ln, which is macro. Inside that, we say something like all rary's private function. If we do call it and we have missed something like semicolon, rary private private functiun private function. At the end, we should use semicolon. Over here also, we should use semicolon. I guess we are moving public function, indirect function. So public function called indirect function functiun. Then we print something like and we don't need to press n, or we can, but this is println, so it'll give us a new line anyways, and we'll get another new line where we'll do this. We'll call what? We'll call the private function. But before calling this private function, we have to use semicolon. Oh shit. We have to call semicolon over here. I guess this is it. Now we are using print, not println. Doesn't matter. Everything looks fine. Let's save it. Now just say rust C and all that. Create type and is equals to lib. So we did not use is equals to earlier. Rust C, and then we say first of all rary, and then we say create type is equals to lib. Oh, Oh, it's not create, it's create. Sorry. Create type is equals to lib. Oh shit. This one is unclosed, so let's first of all close it. No errors should be there. Let's call it again. It gets called. Unless we see something like our libs that we already saw. Now we should use these libraries. So first of all, let's see this. It says that libraries get prefixed with lib by default as they get named after their create files, which is rarely, but over here it gets prefixed with lib, and the extension becomes instead of .r, it becomes .rlib because it is R's library. It's named after the create file, but this default name can be overridden by passing the create name. So as we passed create type and caused it to create a lib, we can also pass the create name and we can then name it whatever we want to by using create name attribute. Where is it declared or where is it being taught? So in a module called 13. So we'll see this. We'll see this very soon. We'll see this. All right. Now the next one, which is the last one, and we have only 10 to 13 minutes remaining. So let's use a library, which is public function and indirect function. And we'll just say use.rs. All right. Damn. Now the command is different because we are using executable.rs. So this is executable.rs and it uses extern, which is now rarely. We are passing the library as rarely over here because it is used as rarely, and then we are passing the library's name and we say ampersand and then we run the executable. So let's create it as using it. Let's create it use not rs. Let's paste it. What is it doing first of all? Create extern create, that is rarely, may be required for Rust 2015. So I guess this was first of all declared earlier in days. Now it is 2025. So I don't think we will need that. It says that main function will run public function of rarely and indirect call or indirect access, which will first of all print the indirect access and then the private access. If we want to see some errors, we can call or try calling the private function, which is private because we have not declared it as public. Yeah, it's a good mode, but we have nothing as rarely. We have a library, so we have to now execute it using Rust C and then executing use.rs. Now we have extern extern lib. No, just extern, and then as a rarely we are calling lib rarely.rlib. All right, let's do that. So it's saying indirect access not found in rarely. Ah, shit. Just spelling mistakes or something like that. In very indirect function, so not access. Let's change it. Indirect, make it indirect access. Indirect access. Same thing. Indirect access. Now let's do this. Create is like not this one. But we just made right now. Oh, but we have not updated. Yeah, we have to update our library. Yeah, now it should run. Like this. It does run right now. And if we see some tree, we first of all see the rarely library and then we see use.rs. So if we try to run the use, which is a binary, use is a binary. So if we try to run use, we should see some Useful things. Yeah, exactly as we expected. Not as seen, because we, instead of using print, we used print ln. So that's why the difference is there. But all right, it's fine. Shall we move on? This is a cargo, which is a 12th module. So we'll start that. Not today, tomorrow. Wow. Crates is not finished yet. All right. Then we have generics. Nice. Nice. I guess we'll try to cover up this, 12th and 13th module tomorrow. For now, bye bye.